All right. So there's plenty of people on the call now. So I think we're good to kick it off and delve into the Domino architecture and the Domino-E project. Michael.
Yeah. So before we go into the details of this very call, we wanted to start off with a very short, a brief introduction to the Domino-E project, what it is all about. Domino-E is quite an ambitious project that is funded by the European Union, and that wants basically to enable 7 partners from 5 countries to democratize access to Earth observation data. More specifically, the aim of the project is to further a federated architecture for satellite ground segments, so to enable users to access Earth observation in a more intuitive, more efficient, and also less cumbersome way. In the project, and you will hear more about that in the session to come, there is teams that are developing applications that will enable the idea of that federated Earth observation ground segment to happen.
Yeah, today is the first of 3 sessions of this webinar series. For those of you who cannot make it to the following sessions, there will also be recordings of the sessions made available. Today, we will kick it off with a brief overview of the Domino architecture, the underlying structure that enables this particular project, Domino-E. In the second session, which is going to air next week, I think it's Tuesday next week, we will look into the examples, the example dominoes that have been developed within the framework of the particular Domino-E project. And then in the third session, in 2 weeks from now, on a Monday, we will delve into the business opportunities that derive from the enabling technology for small and medium enterprises in the Earth observation market. And I think there's plenty of interesting discussions and insights from the projects to come. Yeah, just some housekeeping remarks from our end. At all times of the webinar series, you'll be asked and invited to contribute to it by putting questions to the chat. You also can use your hand up button in order, if you want to ask a question, make a remark, or go into a discussion even maybe. As I said, the sessions will be recorded to make them available in the aftermath of the live streamed session. And of course, we would ask you to mute yourself while you're not talking. Yeah, I think that goes without saying.
All right, so I think we're good to go with the introduction to this very session today, where we will basically start from the history of Earth observation and then explore the current challenges of, and also the current technical, but also political challenges of Earth observation missions. We will talk about or hear and learn about the Domino architecture, the vision that goes with the Domino architecture, and also do we have 2 guests, Daniel Novak and Jean-François Vinuesa from Airbus, who will basically try to explain more, not only the vision, but also the details then of the Domino architecture. I start off with the history and the state of the art for Earth observation mission management. The story of Earth observation didn't really start with satellites or with computers, but actually it started with few bold experiments and a great deal of imagination already in the 19th century. A good example, or the first example, is actually the French photographer Félix Nadar, who became the first person to take a photograph from the air, and he was using back then a hot air balloon above the outskirts of Paris to create this somewhat grainy picture, but it was for the first time in history that people could basically see Earth from above. not from maps or sketches, but directly in a visual image. It was the birth, basically, of the aerial perspective, and it introduced a new way to observe, to map, and to understand landscapes, decades actually before the aircraft was born. Fast forward then, so 5 decades later, George Lawrence took this rather iconic picture of San Francisco. It was San Francisco. It is a picture of San Francisco after the earthquakes that year, and that also resulted in huge fires. And he captured the devastated city and the dimension of this devastation. What made his approach so disruptive wasn't just the elevation. He was basically tying his camera or lifting his camera by using a kite system. But it was the resolution and scale of that picture. So the image was sharp and wide, but it also provided a lot of detail that wouldn't be possible to gain from the ground. So we have kind of an important aspect here. So it's the first time that we have context and detail in one picture taken from the skies to help in disaster management, or to support disaster management, actually. Just a year later then, kind of an interesting idea put forward by Julius Neubronner was to actually attach cameras to pigeons. He strapped the cameras to these pigeons together with timers and released them to the skies. The birds then flew autonomously over difficult terrain, and then returning later with the images that have been taken or were taken in the time in between. This approach attracted military interest, especially during World War I, and it also highlighted basically a disruptive principle that still applies also to today, and that's autonomy. Autonomy in flight and autonomy in the movement of the birds, or later on then satellites. By 1909, or from 1909, sorry, to 1942 then, Earth observation had finally become a matter of national security. Airplanes were to be equipped with cameras and for strategic aerial reconnaissance. And on the picture here, we see a soldier who is operating a Fairchild K17. That's the type of the camera, with a 24-inch lens and approximately 30 kilograms of weight. Now, that was the first time that Earth observation was conducted with a strategic intent, and it also laid the groundwork for what would later evolve into satellite-based strategic surveillance and intelligence. And then there was this moment in October 1946, just a year after World War II ended, when a V-2 rocket launched from the White Sands missile range in New Mexico carried or had stripped down a 35 millimeters film camera, pointing down towards the Earth and taking pictures constantly. As the rocket reached over 100 kilometers in altitude, it snapped the first ever picture or photograph of Earth from space. And yeah, that was again quite a disruptive moment, not just because of the image itself, but particularly because it also made the people aware that we could now observe Earth from, systematically observe the Earth from above, free from any sort of constraints. Let it be weather, let it be terrain, let it be also geopolitics that had shaped the continents for the preceding years. Following these very early developments, we then moved on to the 1950s, where we saw a huge rise of major Earth observation programs all over the world, particularly in the US and in Europe, of course. And each of these Earth observation programs would also mark kind of a disruptive evolution in capability, in accessibility, and also in purpose of satellite constellations. So starting in 1972, NASA, for example, launched the Landsat constellation, the first ever civilian Earth observation program that was to serve science, policy, society. It brought Earth observation to agriculture, to regional planning, to forestry, education, and also to geology. Then 10 years later, France's CNES introduced SPOT, the Système Probatoire d'Observation de la Terre, and it was the first European high-resolution satellite, enabling industries and governments to purchase satellite imagery for economic and environmental applications. And it marked basically the beginning of the commercialization of Earth observation data, and a trend that would not just explode decades later, but it's also a trend that we are, to some extent, also building on in Domino-E. In the 1990s, then, the European Space Agency ESA launched ERS-1 and ERS-2, introducing radar imaging, SAR, to European Earth observation, and that allowed operating independently of LiDAR weather. It allowed for continuous weather imaging and added a new critical capability, actually, for climate monitoring, for example, for ice observation, for land subsidence. Now, each of these missions here and also many others broke new ground, expanding Earth observation's role from occasional observation to permanent global monitoring with scientific, with commercial, and with policy impacts. Today, Earth observation has matured into a globally distributed infrastructure that remains under constant evolution. And I'm just going to pick out some of them. So we have, and I guess you also know most, or at least some of them. We have the Copernicus program, including the Sentinel-1, 2, and 3 constellation that are delivering continuous high-quality data for everything from urban planning to climate science again. It is data that is, at least in parts, free and open access, and marking also, therefore, one of the most important enablers of innovation in the Earth observation ecosystem. We have the NASA Terra and Aqua satellites that are complementing the Copernicus program, or with the Copernicus program, allowing for long-term observation of the Earth's energy, land, and water systems. We have EarthCare, which is a ESA and JAXA collaboration that is pushing the frontier in atmospheric dynamics, also trying to improve our understanding of cloud aerosol interactions. And then there is the Pleiades constellation, the first one, so the collaboration between ADS and CNES, that was or represents a pioneering institutional commercial partnership in Earth observation, and offered a 50 centimeters optical resolution and reliable revisit rates. We are not standing at the end. I think that's also important to mention that. There is, looking ahead, we have, for example, the Copernicus expansion mission from ESA that will address new priorities like carbon emission tracking, thermal energy monitoring, and then there is also the NISA mission that is a collaboration between NASA and the Indian agency ISRO that will deploy dual band radar for high resolution or weather surface change detection. Now, these were to some extent governmental, but then also public-private partnership, collaborations between governments and commercial players. But most recently, we have seen a rise of commercial constellations. And also here, I think what I can give or what I can provide at this stage is only a very brief overview, a brief just mentioning some of the existing constellations, starting from Planet Labs that have reshaped Earth observation with a nano-satellite constellation that is capturing daily images of nearly the whole planet or the entire planet, and therefore also giving the opportunity, at least for some applications, to allow for some sort of real-time or near to real-time decision-making. We have Maxa Technologies as a main player who is offering very high-resolution satellite optical imagery that is supporting defense, intelligence, again, urban planning, and also environmental analysis. There's ICEYE that stands out for their capacities in radar capabilities or imagery, and enables weather-independent and day and night monitoring of the Earth. And then we also have the Airbus Pleiades Neo constellation that blends basically the institutional-grade Earth observation with commercial agility, offering a wide area optical and radar imaging and covering up to 1 million square kilometers a day. Now, together, all of these constellations reflect some sort of a seismic shift from centralized infrequent observation to global high frequency and also high resolution network. Also, the landscape is today not only defined by national agencies alone, but we have more and more commercial players that are enabling also Earth observation as a service, creating new data-driven business models across different industries. So why did we start with the very early images of Earth observation? Looking back at these origins of Earth observation, the balloons in the 1850s, the kites in the early 20th century, the pigeons carrying cameras, it's actually almost unbelievable to how far this field has come in this last century. And however brilliant all of these moments in history and all of these developments were in their creativity, they were still limited by weather, by logistics, by time, and you had basically one shot on one particular day, hoping for good light, for a steady platform, for no clouds, for no wind. So I think that's a good opportunity also to compare to what we have today and also where we could go in the future. So other from Felix Nadar, the picture that you see here once again, we can now operate through clouds. We can operate not only during daylight, but also at night. We can operate under adverse conditions that are, for example, independent from winds. What was a clear sky only endeavor is now a 24/7 monitoring capability that we have through satellites. We also can now track changes in climate, land use, environmental patterns over time and on long term. Also something that wasn't possible in the mid-19th century. And then satellites are no longer passive imagers. They have onboard AI, they have cloud integrated workflows, they have Earth observation systems can nowadays prioritize, they can filter, they can pre-analyze data even before it's downloaded. And all of that is cutting down also the human workload, but also response time. Comparing to the picture taken by George Lawrence, then we can today apply even more developed sensors that do not just see as the human eye sees, but we have access to visual, we have access to infrared, thermal, microwave, radar imagery, active and passive one. And all of that is allowing for a range of applications from heat mapping to soil moisture monitoring, and that's all applications that have been developed over the past decades. Then coming back to the pigeons set free by Julius Neubrunner, I mean, here, unlike the relative unpredictability and the fixed schedules of early missions, today's systems are about to allow for near real-time tasking. They allow for cross-satellite coordination for mid-orbit reprogramming even. So we can adapt to emergencies, we can adapt to shifting needs and to specific user demands. And or at least if we're talking also capabilities that are not yet there, that's certainly something, or that these are capabilities that we are, or satellite constellations are aiming for. And then there's finally the photograph of the soldier handling his Fairchild camera. Modern Earth observation hardware has become, of course, much smaller, lighter, more efficient, more durable, and what once was basically filling up an airplane is now fitting into a small box together with a lot of other items. It is also more distributed, and it is now more affordable. Not all of the items that we have or that are produced today are handcrafted. We have items that are industrially made, and all of that, again, brings down also the cost of Earth observation. So, while today Earth observation systems, including both now satellite constellation, but also ground segments, are basically more capable than their historical counterparts, this evolution, ever new generations, has basically also pushed us to the limits. So there is new users that want faster, more reactive images. They also want it at a lower cost. There's a growing demand for higher resolution and multi-wavelength images with larger amount of data. There is a growing demand for real-time or near real-time delivery, particularly discussing disaster response, security, maybe even time-sensitive agriculture. There is a growing demand also for ground segments that are capable of handling these increased amount of data volumes with a rapid downlink and with automated processing pipelines. And then there is this second part, or the second demand for basically cutting down the costs for more affordable image acquisition, longing or asking for automatization in mission planning, for reducing the reliance on manual scheduling or even expert consultancy, and then finally for lowering the opportunity costs resulting from urgent imaging tasks that are delayed due to rigid systems or to resource conflicts. So the big challenge that we're facing now is to deliver more value with less friction, seamless or almost seamless, and to do so at a scale. And that means rethinking also how we build, how we operate, how we integrate Earth observation ground systems today. And that's exactly where Domino enters, or Domino-E also enters the picture. Now, before I'm handing over to our colleagues that are basically the experts on the Domino architecture itself, I just want to make one last excursus to the tasking loop. So what happens when a person actually asks for a picture from space? So this whole task begins with a customer that asks for a particular image of the Earth. It could be to monitor crop health in this area. It could be to monitor or to get an idea of a certain disaster area. However, this request needs to be first to be translated into a technically viable acquisition plan. It needs translation. That needs also specialist knowledge. And it longs for 30 to 70 minutes until this task is completed, beginning with the initial customer request. Now, once that this acquisition plan is defined or has been defined, the acquisition plan is first uploaded to the satellite. The satellite in the orbit is taking the image, so there's the image acquisition, and then this image is downloaded to Earth and to the ground segment again. And that takes, in the perfect case or ideal case, at least 60 minutes again. And then the final part of this Earth observation tasking loop is to receive the data, to process the data, and then also to send this data back to the person that has first stated the customer request. And that's, again, another 20 to 30 minutes. So overall, this whole tasking loop nowadays takes, under optimal conditions again, at least 2 to 3 hours. And that's, of course, acceptable for some, but it's maybe less acceptable for others. And particularly, I think it's also important here to keep in mind that this very idea of 3 hours is the request for a simple or for a very simple acquisition or customer request. Now, when you have larger areas, when you have more complex monitoring campaigns or multi-mission integration, then this may add significant delays, and of course, then also costs. So the question that arises is very much, can we make Earth observation more reactive? Can we make it more accessible? Can we make it more responsive? And maybe can we do that without reinventing every part of the stack over and again? And I think that's now the moment where I invite Jean-François Binuesa, our coordinator of the Domino-E project, to explain us a little bit more about the Domino architecture, the Domino vision, but then also what a Domino is actually all about. Jeff, the floor is yours.
Okay, thank you. First of all, is anyone at the audience have some question for our colleagues on the presentation? So if not, I can start perhaps. Perhaps you can move into changing the slides. So I'm going to talk today about the vision of the Domino ground segment that we had prepared for over the years for different projects. This will be today's presentation, and there will be another presentation, the third workshop, as you have seen, about the business opportunities. Because at the end, what we want to do is to propose these new systems to the world and to make business out of it. So as Michael was saying, there have been when you propose a full system for export. First of all, sorry, I'm Jeff Vinuesa. I belong to the proposition and advanced project division at Airbus Defence and Space in Toulouse. And in my division, what we do is that we sell full system to export. When we talk about full system, we talk about, for sure, the instrument, the satellite that are going to be the flying system, but also the ground that allow you to, as Michael showed, to control the mission, to order image, and then after to receive the image and also to make it some product for the downstream sector like verticals. Let's say you can have an image and you can extract information for agriculture, for change monitoring, for urban purpose, and also for defense. So when we talk about Ops Software System, we talk about the flying system, so the satellite and the platform and the ground segment. And basically, the satellite, you're going to do it in a couple of months or year to produce it. You're going to send it to space, and then it's there and it's producing image. And the thing that the operator are going to deal with every day is the ground segment. And this ground segment is going to stay here for 10 years. So basically, this is, I believe, the most important part of a space system. Whatever you are doing, navigation or telecommunication or observation with radar or optical. So why do we went to this domino architecture, domino story? Is that what we have seen is that over the years, you are more and more actors with newcomers that are going into the market. So when I'm talking about end-to-end system, I'm talking about countries. So we are used to see the Americans and Chinese proposing system, but you have also the Israelis, Korean, and other emerging countries that are going to propose system, and that kind of disruptive the market because they are very fast and they propose system that are fit to a certain needs. And what you see is that the customer needs are evolving with time. So what you have done in the last 10 years ago for a certain customer, now you cannot do it anymore because he wants more. You want to have something that is faster, more precise, and that you have the loop of the ordering that Merkel presented from the beginning to the start to be reduced, so that the time between when you order an image and the time between you have the result is shorter, whatever you are in the system. And also what we have seen with the customer that we have is that before you wanted to have an end-to-end system with one satellite, an optical satellite, or a radar satellite, or something with navigation. Now, the client wants all-in-one. He wants to be able to address from his ground segment multi-mission. It means that you can have optical satellite with different resolution, but also different sensors from radar to optical to navigation, and all in one ground segment. So it means that your system is more complex because you have to deal with different operational phase, with different system and different language. What we have seen also, and actually with this current day where the geopolitics is moving, is changing, is that we need to have in our system more true stability, meaning where we need to be sure that the data we are getting at the end has not been tampered with. We need to be sovereign, meaning that we are in charge of all the ground segments and all the data treatment, and we are controlling it. And we need to be able to use new technologies, meaning deployment on the cloud, that can be local cloud on your premise, or a public cloud or outside cloud, wherever is the most comfortable, the more efficient in terms of time and also in terms of money. So your system needs to deal with different areas of deployment, different level of security. And at the end, the client, he wants everything faster and cheaper. So he wants to have something delivered not too far away from the when he orders the system, and he wants to have something that is cheaper with less risk. So it means that you should be able to have a product-oriented strategy and to have something, not everything on the shelf, but almost in the shelf that you just have to deploy one time to reduce the risk. So what we have seen is that basically these things mean that you have a modular architecture, is that you have the ground segment that is basically 3 or 4 blocks. You have the image ground segment that is going to take the data from the antenna and to make it in a product. You have the mission ground segment that is going to deal with all the scientific characteristic or technical characteristic of the system. And you have the control ground segment, control subsystem, that is going to work with how you are going to check on the safety of your platform, to do the maneuver and all this kind of thing. And in addition, as to system, you have the user access, where the user is going to use your ground system. And basically, what you see is that you need to be able to change some part of it without disrupting the rest, because you can have for a dedicated project a client that want to have something built on, I don't know, artificial intelligence or closing the loop with a different way that you are doing. So you want to be able to propose him to include his feature in your system without destroying the whole architecture. So you need to have a modular architecture and with some interfaces between two systems that are standardized. Is that when you change something, you don't destroy everything. Can you move to the next slide? So the added value for this kind of system is that from the client is that it's easier to set up industrial scheme, is that it's easier to do who is doing what, which are the responsibilities, and which are the term of evolution, where each subsystem is going to have this evolution of complex system, and to be sure that you have the MCO, the maintenance going well. And also, what is nice for the client is that you can choose the best technical solution. And you can have some dedicated feature from this client that would be not for the other one, dedicated to the market and to the client. And again, you're doing this without disrupting everything, without destroying what you have done before. So you are capitalizing on existing assets. So since you are doing this, it's less risky. And basically, you are going to implement your evolution with less difficulties, easier. And you are increasing the confidence level of your teams and of the clients. So basically, you are easy when you're going to take decision calibration between the CapEx and the OpEx. The CapEx being the initial investment that you will need to have your system, and the OpEx that are the operation expenditure, is that when you have to update or to change some part or to maintenance some part, you can be easier on this. What is nice from the industrial point of view is that also when you have this subsystem and this brick, these dominoes, you can easily share the responsibility between the subcontractants and the that are going to design and to build the dominoes and the integrator, the industrial integrator. And it will be easier during the program. So basically, you're going to have some gains during engineering and integration by sharing responsibilities. And what is also very interesting when you look into the development phase and implementation is that since you have already some dominoes that have been de-risked and that have been already implemented, you are going to have less risk into engineering and also an easier integration, verification, and validation phase, because part of it is already done. Because also basically each domino is going to have its own IVV, and at the end you will have just to do a global IVV of integration on your system without going into detail. So basically, you have less risky development from the supply chain, and you have secure margin because each dominoes have its own planning, it's independent, and it will not act and depend on the other ones. And what is nice also when you have this interface that are standardized is that you can focus on your job. That the job basically is to have better performance and good performance for your system. You don't have to deal with standards of interface and how systems are going to communicate. This is not the job of an integrator like Airbus. And finally, if you look into in terms of investment, what is nice is that since you have defined this architecture and you have some dominoes on the shelf or with their own product life, basically you have a clear and stable technical condition for the integration of end-to-end system. So it's going to be easy for you. Even if you are an integrator of different subsystem dominoes, or if you are a builder of a domino, to have a clear product strategy and to be able to maximize the reuse of your product. And in terms of maintenance, well, you have better and easier evolution and maintenance contract with the client. So a lot of added value from this kind of architecture. We can move to the next one. So what is a domino? Basically, as I was saying, a domino is a subsystem. So it's a part of the architecture that is delivering a service for the ground segment. And each domino developer is doing his development in agreement with the architecture and is fully responsible to what's inside the domino. The interface, we're going to give him the interface, the way that the domino is going to communicate with the system. And what is done inside, we're going to tell him which kind of feature we want, but what is done inside, this is the responsibility of the provider. And he's going to do as he wants, because at what we want at the end is a kind of a service from this domino. So a domino is going to autonomously produce output from a set of inputs, provide a different set of service. It can be deployed on the cloud, in-house, bare metal, or outside, or even a public cloud. And as I was saying, is independent from all the architecture of the domino. And it's responsible for this own performance. And what is nice is that it can be changed, or it can be replaced when you do another implementation, and you don't disrupt everything. So it can be basically a lot of things. It can be dedicated to multi-mission or only one mission, because if you have a domino doing with algorithm for image treatment signal, you can have only one mission perhaps, but you can have some dominos multi-mission that are going to deal about the service to send the signal, send the request to different antennas. You can, I was saying it can be delivered as service or a product, and it can be deployed in the unique instance or multi-instance. We move to the next one, please. And okay, this is a setup of guideline that we have developed for the domino. So I'm not going to be more into detail. Is that basically our approach is to work on a collaborative approach on a model-based engineering. So you've seen on the web on internet, we'll have on the Domino-E space webpage, we'll have the architecture that is open, that is released until Apache, so you can have some idea what it's doing. And what we are doing in the architecture is that we are defining the interfaces using existing standards, nothing fancy, nothing new, only what is really efficient and useful for ground segment. We're also defining some guidelines for homogeneous, for cloud development, for security. And the idea is really to have some modularity to be able to push a certain industrial vision, and most of all, to be fully agnostic. That basically we can work on any kind of cloud technology, and we can move to one to the other one. And perhaps to the next slide, please. What you have on the slide basically is that you have an ensemble of the domino that can be offered. So it's kind of a catalog of subsystem of dominos. And what is interesting for this reduced start architecture is that you decrease time to market, because you start with your baseline, and then after, depending on what you need, you can decide to instantiate some of the dominos, not all of them. So you're going to remove the dominos that are not relevant for the project. And your system, your architecture is still fine. It's doing fine. You're not destroying anything. And then the second step will be to work on who is going to do the job, who is going to be responsible. Since you have a domino approach with subsystems that are independent, only relying on standardized interface, you can basically decide it to outsource part of it, to subcontract. So for instance here, because of the color, you've seen that we have subcontracted one domino or several dominoes to 3 other companies in this case, because there are already something that is better for the client, or they offer some new functionalities, or there's something that was pushed by the client, whatever. We have to look on what is best for the client. So we can change the industrial organization. And then after, you can decide where to deploy it, because you can deploy it on the client premises, but also on the cloud, on the public cloud, and everything should run independently. So that's all what I wanted to share to you for today. It was a kind of how we are going to, we can instantiate the domino architecture. And I think that that was my last slide. So if there are any questions, please take the mic.
Are there any questions for Jean-François from the audience? If not, I would, Guillaume.
Hello, do you have some common services in order to, for instance, centralize security logs or some monitoring information in the Domino architecture?
Perhaps Daniel?
Yeah. Hi, hello, Guillaume. There are two dominoes, one related to monitoring, centralized monitoring. One is like operational monitoring, and the second one is security monitoring services. So the acronyms is OMS, SMS. So yeah, those are what the services that allow an end user or the operator actually to have a global overview of the health of all the dominoes and the end-to-end system. And also, yeah, the security monitoring service is the one that that gets all the security incidents and security-related logs and highlights to the operator or the security officer the general security status of the system.
Okay, thank you.
All right. Are there any further questions? Otherwise, I would proceed and say thank you, Jean-François, for your presentation. We have now gone through a little fast forward through the history of Earth observation technologies, and we took a first deep dive into the Domino-E project itself and the idea of the dominoes and their modularity. And yeah, that one question was answered by Daniel Novak, and this already hints at the role of Daniel Novak in the domino architecture. He's like on a project and product management level of the domino development. And yeah, we will proceed now and take a closer look at what are the origins of the domino architecture and the history of this particular project. And for this, we will take a look at a short video. Please, Michael, hit the key to play the video.
I am Daniel Novak. I work in Airbus France in Toulouse. I was leading the first Domino project, Domino-X, and I am currently working on a project for the European defense. The future Earth observation constellations will be more complex, more heterogeneous. We have optical and radar and hyperspectral and many kinds of satellites. And so that's led us to this conclusion that we have to agree on how we cut up the ground segment for observation missions. And then it will be much more easy to put things together. It's maybe a new way to think, but yeah, a new way to do, a new way to collaborate, focusing really on the value added. So obviously the first, let's say, 2 years was, let's say, inception, where we had to define, okay, how we want to do things. Now we're maybe around 3-4 years into it. And yes, I can say there are some dominoes. There are some companies who already are domino compliant or who are selling systems that include dominoes in themselves. So yeah, and then the more we engage with companies, the more they're interested. So, and they understand the purpose, and they understand that this is so far the best answer we have for them. So we see a dynamic. From the system integrator perspective, there's two things. One is the speed of integration, because everybody agrees how things should plug in together. Another advantage from the system integrator perspective is that it's much easy to go pick and choose the best product for one domino and get the best of all worlds and put them together more easily. Whereas until today it was a bit more like spaghetti, or like, you know, difficult to split things and get really the best products all together. We see that some clients around the world, many clients are kind of emancipating in the sense that they want to do things, more and more things in their countries, but they cannot always do everything themselves. So in an ideal world, there would be maybe a official Domino stamp or a certificate, you know, saying that a company with its product A and B are Domino compliant. And then it's easier to tell them that, okay, this or that piece can be done in their country and that it can be easily integrated in the final system. People underestimate the power of these dominoes because it sounds quite an engineering, you know, topic or very kind of a technical thing, but it can have really a profound impact on the value that is brought in the end to end customers.
All right. So as you've seen earlier, he's here with us today. Daniel, thanks for being here. I hope it was okay for you to see you speak on video. That can be not so easy sometimes, but I hope it was okay for you. Now we've learned.
Yeah, I agree with what I said. So it's fine.
That's good. So we've already learned that you work for ADS in France, and that you've been involved in the Domino-X project already. Please explain a bit more to the attendants today about your background and how you got involved in the development programs for Earth observation ground system architecture. Briefly, who are you and what takes you here today?
Sure, yeah, and thanks for this opportunity and inviting me to this webinar. Very honored. So who am I? My background. I've been working in space, aerospace since very long time, since actually I started my career, always in Earth observation. Why? Because I'm just interested in space. And I'm working with Airbus since 8 years now in France. There too, always around Earth observation. Some years in ground segment and ground segment engineering, especially, let's say, R&D or future developments. And then I also started to work on, let's say, more end-to-end systems, and now lately on a European defense project. And so for 2 years, between 2021 and 2023, I had the privilege to lead, let's say, the first Domino project. It was called Domino-X. As you might have seen in the video before, it was more or less the inception. So the origin was around 2020, where we recognized that always we have the same kind of functions in Earth observation ground segments. So we're discussing this with colleagues quite a lot, but then each new program that starts, it has a different architecture. The teams cut up things slightly differently, but without real reason. And so that's how we set out this project, Domino-X, in 2021 to start really laying the groundwork of the standardized architectures, which, as I said in the video, it's not purely a technical transformation. It is a technical transformation, but the point is to enable through this technical transformation also industrial transformation and potentially, market movements as well, on positioning some system integrators or technology providers better towards what they are really good at or where they want to go. So how I ended up on this Domino-X project, it was essentially because I was interested and I believed also in this vision. I still do. And even though the first Domino project, the Domino-X, finished end of 2023, there is this Domino-E project that is a follow-on and a very important one that further consolidates and extends some activities from the initial project. So yeah, I hope this provides a good overview.
Thank you, Daniel. I mean, you have mentioned that paradigm shift that led to the Domino-X project some 3 to 4 years ago. When we think of the geopolitical situation, the economic situation back then, it was somewhat different from the situation today. Can you maybe go back to those days in the early stages of the Domino-X development and explain to us a bit, how was the need for this project identified? What were the main drivers to say, now it's time for doing this sort of paradigm shift in how to approach the development?
Sure. So we saw that with all the Earth observation programs that we were delivering to our customers, be it to governments around the world or defense customers in Europe, we saw that essentially the functions of those Earth observation systems were always very similar. There was always mission control systems with always the same kind of sub-functions. There's always a control system for controlling the satellites, so satellite command and control. There's always some security functions. There's always payload data processing functions. These ones, you always see them. And we also saw that in the Sentinel missions, so those are the Copernicus program of ESA, on the image processing part, ESA has implemented very robust and flexible interfaces between different parts of the payload data processing segment. So we saw that, well, what ESA did on one part of the ground segment, it would actually make sense to be extended to all the ground segments, to extend that philosophy and the technical approach. ESA, for these Copernicus missions, they defined, for example, catalog services and monitoring services, archive services, and each one separately deployed, separately produced by different companies, but all discussing between themselves via interfaces that were agreed from the beginning and standardized and based on standards that are available publicly. So really open interfaces. And so we thought, yeah, this could be a good answer to focus efforts on next Earth observation systems towards agreeing certain interfaces and focusing on the different value added from each provider of Dominoes. And so this recognition that we were working inefficiently on the multi-program level, and the fact that ESA found an interesting way to address things on one part of the ground segment, made us realize that, okay, the right way to do is to extend what ESA did to the foreground segment. And another conjuncture here, like another thing that enabled the creation of Domino initiative was is the European reload program after COVID, where, if you remember, a few years back, there was a big investment via European sources to boost competitiveness of European industry. And in Airbus, we applied for such funding together with 10 other partners to, let's say, lay the groundwork on this standardized architecture, because we believe it is indeed allows a boost of competitiveness for all of us. So this provided more or less these were the, let's say, ingredients or the sources and events which led us to really kick off this initiative, first through a proposal, but then through the project.
Thanks, Daniel. Domino-E and also Domino-X were no industry-alone projects. You mentioned the public funding for it. From the perspective of ADS as a system integrator in the EO domain, who's the driving force in the industry for the development of the Domino architecture? Is it singular business entities? Is it the system integrators' perspective? Or is it the ongoing development of modular components that required that system shift on its own logic? Who are the driving forces behind this development, or who were the driving forces?
Well, there's different actors, and we actually see interest from different types of actors. Obviously, I won't mention us, Airbus, because we still believe in it and we're pushing towards it for future programs. But also, we see interest, for example, from subsystem providers. I know, for example, Lean Space, but others as well are pushing it within the circles that they are involved in. And we also see interest from agencies. And yes, this approach, you can say it's already a few years, it started, true, but it's a long-term initiative. Standardization takes always a long time. And we do see that those will really, let's say, provide the lasting setting for the Dominoes will be future, let's say, actual programs and possibly large programs. So if future programs like Earth observation system programs, like government or military or European defense, adopt this modular architecture, then it will, let's say, set or guarantee for longer time the presence of this Domino architecture and its maintenance and all the dynamics associated with it. So, and we see this happening. We know that some companies are already implementing Dominoes in their programs. So this means that since these programs can last 10, 15 years, that means there will be places already. And now we know that there will be Dominoes for at least 15 years. And obviously we plan to have more programs adopting more of this approach. So system integrators have an important role here because they're also at the forefront of building these programs and allocating to different subsystems, to different products and services, the various industry players. So many people have their role to play. They all have to work together. It raises the question of the technical governance, obviously, of the dominoes and the interfaces, which are looked at in the various avenues. And in this technical governance, we do believe also that agencies have a role to play, just like ESA is doing on Copernicus, maintaining the definition of some interfaces. So
Daniel, sorry to interrupt. Maybe we can take a look at the challenges, because you're mentioning the governance issue, the technical governance issue. Before we get to the challenges, maybe let's take a step back, because we've now looked at the idea, the basis of the Domino architecture, but it has matured since the Domino-X project kicked off 4 years ago. Maybe give us a little overview on the state of play now. 4 years into the development, where do we stand with the Domino architecture? Because as you said, usually technologies will have to last, because you cannot have this really rapid development of new technologies. This is why standardization is so important. What's the state of play? How does it evolve? Fill us in on that, maybe, if you can.
Yeah. So I said earlier that we know already that some programs and some system integrators have already implemented dominoes towards their customers. Some dominoes. We also are in the meantime further developing and testing new dominoes, like in Domino-E. And we also know that there are upcoming programs that will improve and inject dominoes in themselves, especially defense programs in Europe. So the status today is that we have an architecture with 20 odd dominoes, 22, I think, 23, defined. They are defined at a sufficient maturity level, typically at the PDR level, which is a good level. And some dominoes have been implemented already. And so the objective then is to inject these into the coming programs and further develop these other dominoes. So we're still in let's say in the phase of increasing, or adoption and maturing of the dominoes. Once we have a couple of running programs that adopt them, which with the signals we believe it will be the case, then this will be a lasting initiative. So yeah, today we're still, let's say, in this maturing and adoption phase.
Okay, and then you mentioned the internal governance, the technical governance of the whole architecture, which may lead to challenges. I hope not too much, but maybe there are some obstacles, because no project of this magnitude comes without challenges, I assume. So maybe you can delve a bit into what hurdles there are still to overcome in the rollout and the maturation of the architecture.
Yes, there's challenges of different nature. Very often, for example, those actors like subsystem providers who already have their own products in place, well, there will need to be an evolution of some of these products to adopt the right interfaces. It means potentially investment. So further still need to get the word out that it is in the interest of subsystem providers or technology grid providers to invest in this evolution of their legacy products, so that it opens up new segments and new possibilities, new systems in which they can inject their products. So we have to keep the word going, just like we're doing here, and you guys in OICO are also doing a good job on LinkedIn and elsewhere, that this is a concrete solution which provides, which is of interest. We will also need to obviously get more involved agencies in the technical governance, because at one point, once there is more and more adoption, which we believe it is the case, we need to still keep a baseline, like a standard, and we need to agree on those. So if there's a program that develops something that didn't exist before, but which we deem useful for the common standard, then these new developments should be given back to or flowed back into the standard with agreement and in an appropriate governance model. So there's all this still to let's say set up, and this come as the problems arise, we will solve them one by one. We won't do let's say a big bang approach where from a day to the other we declare that what is out there as Domino today is the only way to do. The precise interfaces and the data that is defined there is exactly that has to be there for the next 15 years. No, like every standard, certain evolutions controlled and the right governance model need to be put in place. So yeah, I think the challenge is still to get this dynamic going and to have more and more programs adopt these Domino architectures, be it commercial programs or agency programs.
Thanks, Daniel. I think that step-by-step approach when it comes to overcoming challenges sounds very reasonable. And you mentioned we need to get the word out. This is precisely what we're here for today. So if you would try to shift the perspective and think through the Domino architecture from a developer's, contributor's perspective, what would you say is the value proposition the architecture can provide to them? Imagine you're a company working on a very specific solution for a problem in Earth observation. What's the value proposition of the architecture in onboarding the Domino architecture and interfaces?
Sure, it provides clarity, and clarity de-risks schedules and costs. So, for example, subsystem provider, if it wants to provide its subsystem to a new program, it will likely receive an RFP, request for proposal, from an agency or system integrator. And in that data pack, there will be statements of work, there will be specifications, and there would be interface definitions. And these would be the Domino interface definitions. And by applying these interfaces, it's very clear who does what. So it's very clear from the very beginning, from actually the proposal phase, like who will be responsible of which part of the system. So are you like falling left or are you falling right? It's very clear. And so this clarity allows really to de-risk, development plans, costing, and so on, and therefore become more competitive, basically. This really brings this advantage. And if you have a clarity on how you will integrate your product into other systems, and this clarity is like stable for 10, 15, 20 years, maybe with minor adjustments, of course, but broadly stable. Then as a provider of a domino, you really can start focusing on the content of the domino, the value added, where you really want to differentiate yourself from others. And you don't need to spend time on trying to integrate what you do into the other systems. You spend time on really bringing as much value as possible within your own products. So this is really the value proposition to these domino providers, is that it enables, let's say, product approach, it de-risks programs, it like schedules, it de-risks cost. You say time is money, so in the end, everything is de-risked in terms of cost. So this is really the advantage.
Very nice, thank you. Let me just hint on the second session of this webinar next week, because there we will actually talk with people who are contributors to the domino architecture, and they also bring in the perspective of enterprises in the space domain who actually try to make an effort and be pioneering in building domino compliant solutions. I think that will be very interesting in that regard. But for today, before I would like to leave the floor to the audience and ask questions on their own, I would ask you, Daniel, to give us a little look into the future. Where do you see the domino architecture and following domino projects evolving? This can also be a very personal outlook. Where do you see it? What direction will it take? Should it take? Where do you see it in the near future of like 5 to 10 years, let's say?
Oh, I do see a future of this domino architecture. We do see an interest. We do see funding going into it. We do see that standards of this kind make a lot of sense. So I'm not too worried. Actually, I'm quite positive about the future of domino. I don't have a crystal ball, like precisely how things will look like in 10 years, but I'm sure that there will be projects with interfaces of the kind that we are defining. So like data-driven architectures and the associated interfaces, OGC kind of standard APIs, different things like this that you actually see in the domino architecture. So I do see a future for it. I do see a dynamic on it. And so I'm quite positive about it. On a personal note, I'm also leading a project today for Earth observation systems for European defense. It's still, let's say, a phase A/B, so early phases. But definitely we will adopt the domino interfaces in there. We'll see precisely where, like there's no need for big bangs, but certain parts of architecture that were defined already will certainly find their way into the program I'm currently leading. And so I believe programs will also follow the same way.
That does sound promising. Thank you. I think it's always good to have technology projects like Domino-E or like Domino-X or like the Domino architecture explained by an actual person, and not only have it explained by slides or fancy videos or whatsoever. So I think there's a huge value added in having you here with us and explaining the whole idea and the status of the ongoing developments. And I would now ask the audience if there's questions that can be directly addressed to you or also to Jean-François, who's still here. please, if there's any questions from the audience, go ahead. Benjamin, please.
Yes, hi everyone. Benjamin from IRT Saint-Exupéry in Toulouse. Daniel, could you tell us what Domino-E is with respect to the previous Domino-X initiative? I mean, is it just a follow-up of this project, or is it more focused on some specific component of the ground segment?
Maybe I let the floor to Jeff, because he's actually leading Domino-E, so he will be the best.
Yeah, thank you, Benjamin, for the question. So basically in Domino-E, we are focusing on 3 services that are related to the multi-mission Domino. So there's a first service that is for coverage service. And basically the idea is that you have an end user that want to cover an area of a country, and he has access to a lot of different assets. It could be his own assets. It could be assets from some commercial provider like us or like Maxar. It could be an asset for another country. But he's going to say to the system, I want to cover this area of my country, find the best solution. So the service of coverage, we have 3 different use cases. We presented in the next session of webinar, you will see it. And it allows you to dispatch the request on different satellites, and then at the end to reconstruct the image to have a global image for the end user. The second service is about how you are going to send the request or to retrieve the data from the satellite. Because as I was saying, the clients, they want everything faster. So when you are producing a request, you need to send it to an antenna. You can have your local antenna, but you can also some network antennas if it's easier or cheaper. And so the idea of this service is to find in a dynamical way the best solution to send and receive the data, best solution in terms of efficiency, in terms of performance, but also in terms of money at the end. And the third service is more related to the interface with the user. And the idea is that you have a user that is not an expert and is going to express a need. As I was saying before, yeah, I want this part of the region of the country covered by satellite in 2 months. And then you will have in the system, let's say, a natural language interpreter that is going to translate the non-technical request of the user into a technical request of the system. So this is the third service. This is a virtual assistant service, and will be also presented in the next session.
Okay, thank you. It's clear. Thanks a lot.
Thank you. So if there is any other questions, please just raise your hand, or also feel free to write them down in the chat.
Yeah, and if there's no open questions remaining, I think, yeah, we can again invite you to also attend the second session of this threefold webinar series. I think Michael has just posted to the chat the Eventbrite registration link. We would kindly ask you to spread the word about the webinars, and also if you cannot make it to the actual live recording or the live call, the stream of the webinar, there's always the option to watch them on demand on YouTube after we've finalized the series. And then let us also hint on the program for next week's session. I think this really links in with the last question we've heard from you, Benjamin, what Domino-E actually is about, because Domino-E provides 3 example solutions, or it's not only example, it's actual solutions that draw upon the Domino architecture. And in next week's session, we will have with us colleagues from ITI, a Poznan-based company in Poland. We will have colleagues from Honora, the French aerospace lab, as well as from Capgemini, and also from Tilde, a company based in Riga, Latvia. They are actually developing the natural language assistant that makes customary requests to ground segments much easier. That's what the developments promise to add to the Domino architecture. Michael, is there anything you would add?
Well, no, thanks a lot. Thanks to all our guests. Thanks also to all the participants joining, listening, asking questions, hinting us to unanswered points also. I think we covered a lot of ground in this session today. Was basically introducing the Domino architecture, where it comes from, also looking at where it goes to and what it is intended to do. I'm looking very much forward towards the next session. And again, feel free to register. I think that's it for today. We can wrap it up. Thanks, everybody, and see you in session 2, I guess.
Yeah. Bye, everyone.